Hey everybody, welcome back to the Metal Mill 52 workshop. My latest project is Quorn Tool Grinder, and the latest part of the project is the 5C tool holder. I got this casting from Gary Martin at Martin Model and Pattern. He sells the complete castings in the US. He's the supplier for the Quorn project, and a real good guy to deal with. Give him a call on the phone and order. We've got no connection other than I've been a happy customer. So here is the finished thing. I need to do a few more things. I'll probably do a follow-up video when this is all said and done and point out some things, but if you'll stay with me for the next 20 minutes or so, you'll see the machining of how I did putting the cotters in place, and then machining the bore, both of the bores, and drilling and tapping the holes for the end plate in the back there. A couple things I need to do. I still need to stamp the numbers in here, and there's a lot of finishing touches obviously to put on this thing, so that'll be a project or material for another video to show when it's all completed. One last pitch: the groups, if you're going to build one of these, groups.io, the Quorn group is very helpful, and that's where I got in contact with Dan that provided the drawings for the updated drawings for the plunger, and it's been very helpful. So stay tuned for the next 20 minutes or so, and I hope you enjoy the video. Welcome again to the new subscribers, and please subscribe, please pass the word, and please add your comments and questions. I really enjoy the participation that we're getting through the group. So thanks again, everybody. Everybody, working on the castings finally for the 5C tool holder. First step is to mark out the place for the cotters. And what I did was I put dowels in here, wooden dowels, and I marked the center of them, so I was able to get at least the center of the core hole, and I could mark the offset for the bottom, which is 460 thousandths of an inch. It's nice that they give you those dimensions in the plans in the on the Quorn.io group. So this one's marked out. I'll need to mark the vertical line, but that's easy. And then I'll flip it around and mark the other side. I'll bring you back for that. I did want to point out before somebody makes the comment, you can't rely on the core hole completely, and you do want to make sure this is the 2-inch offset. So I eyeballed this. I did line up here. It's hard to see the small one, but the centers of the core are actually very, very close to 2 inches. So in case anybody's worried about that, since I'm relying on the cores for my markings, it's something you definitely always want to double check. These castings are from Gary Martin at Martin Model and Pattern, and they, as I've commented before, they are fantastic. I really am looking forward to machining these things, because this cast iron, like I said, I don't know for sure if it's got a lot of graphite in it or not, but it machines beautifully. The pillar tool that I made over here, that was, all the castings came from Gary for that also, and they machined really, really nice. So sorry about zipping the camera around on you like that, but I did want to point that out. So here's how I went about the layout for the top part. The offset is 910 thousandths, so I just lined it up here and moved it up, and lined it up, zeroed my scale, and moved it up 910 thousandths, and off we go, marking the line. As you can see, I've got the center part marked there and a little center punch for the eventual drilling. Here we are drilling out the cast iron for the split cotters. You can tell I've got the bridge port in reverse, and I'm using it very slow. Back gear. You can see how nice the filings are. That's a plastic bag with a magnet in it. Here's the cast iron collet blank. I just drilled and reamed a 5/8 inch hole in the top here for the cotter, and I'm getting ready. I've already done the bottom hole. What I do is I put it in with crazy glue. I clean out the hole first with some cheap acetone, and then I use crazy glue, and it works amazingly. This is the genuine crazy glue. Pour some of it on the thing, pound it in with a rubber hammer, and you're good to go. Let it dry overnight, and I can start machining tomorrow. Couldn't resist taking a little video before I start machining. So I've got the cast iron part in the vise. As you can see, I've got a ton of brass and copper pieces all shimmed up I've got it shimmed up rock solid. I got my cutter, my favorite carbide tipped cutter that I use for machining cast iron, down, set my D-row to 0. And my whole goal here is I got this thing, it's all shimmed up and packed in there as level as I can get it and as secure as I can get it. I smacked it down with my dead blow hammer. And the whole idea here is just to take a skim cut or a few skim cuts and bring this down flat. So I'll have a nice flat reference on the back side, and then I can flip it over and tomorrow probably do the front and you make that flat and put the 1/2-inch step in it, and just like I did the other one. And then when that's done, then I can reverse it, pack it up again, and I'll have it nice and flat on the other side with the 1/2-inch step already in. I can mill the back side to the final dimension lengthwise, and then commence with the boring. So when I pack it up again, I'll have to be real careful not to have stuff interfering with the 5/8" hole and what will become the 1.5" hole. That's a whole different challenge in setting it up, but I'll cover that as we go along. And here we are, just finished the first set of passes. In total, I took 100 thou off of here. Just got a nice level thing, so now I'm going to unpack it, take it all out. I've got my plastic bag with magnet in there to pick up the iron filings again. So I'll pick it up, clean it up, measure it, flip it over, repack it, get ready for the next step. Took it out, measured it. It was 3 1/4 inches from the back side to the front side. So I have 250 thou at least that I can still take it down. So I'm going to take this side down flat, and then put my 1/2-inch step in, and we'll see how much material I need to remove total. But looking good so far. As you can see, I've got it chalked up pretty well, got it supported on the base here and tapped in. I've got I put my aluminum soft jaws in my vise here, and because they're good for gripping cast iron, and smack it down good with your dead blow hammer and make sure it's quite secure before you start machining it. Because the last thing you want that to do is to move at all while you're running a carbide cutter. Okay, I thought it'd be good to take a little action shot of machining. And here I'm taking the final about 15 thou off. This is the front part of the casting. I'm really pleased with how this came out. I've taken turn this off. Taking 1/8 inch off total. Might take a little bit more. I think I'll take another 10 thou or so off of that, and then from that point, then I'll make this part a 1/2 inch lower. I'm going to need to make sure that my blocks are not in the way there. I should have checked that beforehand. Okay, there we have it. Pretty nice, successful night of machining. I got this part and both the main part in the front and the lower part that makes contact with the rotating base. Got them all milled flat and a 1/2 inch spacing there. And I took the file to it. I don't know if you can tell that or not, but since this is going to get flipped over, it's going to become, both these surfaces will become my primary reference for the rest of the machining. I took a file to it and deburred the outside of it a little bit. So I think we're looking good. I'll bring you back for the next phase. Hey everybody, one of the critical factors in machining the casting for the 5C tool holder is the distance, the length of the spindle. And the drawings actually have a way of coping with this. They say to make the spindle length, the free length here that my thumb is going back and forth on, the length of the casting, the finished casting. And so one thing I wanted to do in preparation of machining the casting was to put the index plate on, and I've already Loctited this ring in place, as I've already covered. So I measured the distance and I realized that it was actually a little bit uneven, and the reason that was because the ring here on the cone or nose ring, whatever you want to call it, was actually uneven on the back. So what I just did, I put it in the forejaw, I carefully centered the spindle again, and then I just trimmed off a little bit right where my pinky is here. Actually ended up taking off 75 thousandths of an inch, and I got it completely uniform. Then I polished everything back up again, and I've just measured it. I've got this cool 12-inch Starrett dial caliper that has long internal fingers, if you will, on there. So I just measured it, and it's a uniform 2.996 inches all the way across. I took it in several different places. So now I know that that's my length. The target length is 3 inches. So if I've got that within 4 inches, the trim ring you'll notice is thinner than the drawings call for. It's right at 1/4 of an inch of all things right now. It's supposed to be 5/16. So anyway, with the front and the back all trimmed up, trued up and everything, I think I'm really happy with the way it is now. So now I've got a target length for my casting to be right at 2.996, 2.995 inches, and that'll give me a very close fit on the spindle here when this is engaged. Thought I'd cover that for you, and I will bring you back for some more of the machining of the actual casting. Okay, here I am holding the casting in the forejaw. I think I'm onto something because I'm really happy with. I haven't centered it up yet. It's cold out here tonight. I'll probably I'll work on it centering up a little bit and see how that goes. But here I've got it at 220 RPM, and check it out. Not much wobble on the lathe. That'll be plenty fast enough for cutting it. And I know I can bore it out with my 3/4 inch boring bar like I used for the locomotive cylinders. I've showed that in this project. The biggest concern I have right now, I'm going to have to offset it just a little bit because, let me show you, with 2 of these jaws turned around backwards to hold the odd shaped pieces, this part of the jaw, which is hardened steel, is sticking into the place where the cutter, the boring bar, is going to go. You can see right here where my finger is. So, and that's inside the realm of the, put a little metal rod in, I'll show you what I'm talking about. So, put that in there. So you can see where the boring bar would be. That's going to hit, it's going to interfere with that. So I'm going to have to offset it a little bit. But I'll play around with that, and then I'll need to get it as centered as perfectly as I can. And if that all works out, then I should be able to face the back to the final dimension, basically just taking off 60 thousandths of an inch and then boring it out and doing the outside feature, the outside 1.75 inch, so that it'll fit the back plate. And then I'll have to take it over to the mill to drill the 2 holes, but that's no big deal. And also bore the 5/8 inch hole. Okay, I'm hopeful this is going to work. I put a spacer underneath the base of it. It'll give me 1/8 of an inch of clearance. And then I carefully centered it as best I could. Mind you, the indicator is on the core hole, which is not a bored smooth hole, and I've got it centered within, plus or minus about 5 thou all the way around. So I'm pretty happy about that. I don't think you could do better than that for centering. And I've got it nice and firm here. Everything's tightened up, so I think I'm going to give it a whirl. It's all firm against the base too, so hopefully this surface will be parallel with that one. That's another consideration. Fingers crossed. I'll give it a whirl tonight. Tomorrow. It's cold and late here on a Friday night, so I'm going to give it a try tomorrow. We'll see how it goes. So here we are taking the first pass. In the four-jaw chuck and taking off 16 thousandths of an inch, total of 60 to remove. And RPM is 220 RPM, which I really wouldn't want to go any faster with off-balance load like this. But you can see I got it lined up really well. The outside, you see a little wobble, but the inside is pretty rock solid. So the game plan is true up the back first, take off that 60 thou that I need to, and we'll start boring up the large hole. I'll bring you back when we're ready. Okay, the 4-jaw machining, that worked out really good in the lathe here. The next, I was thinking about going ahead and turning down the 1/8 inch shoulder while I've got these tools in it, but I thought one thing I need to do is to I'll get the center bore lobe turned out first, and then we'll do that part. So here's the boring in process. I got the automatic feed going on the lathe. Carbide cutting tool. I'm taking off about 40 thou, opening it up about 40 thou per cut. So I've got the short of about 40 thou. same 220 RPM, and no real vibration. There was a little bit when I went through the brass where the cotter is, but it's, I wouldn't want to go any higher on it. Okay, this segment I'm test fitting the back plate. As you can see, it's about, I've cut in about a 1/16 of an inch. I've got a good fit there around the center part, and then a good fit here in this lip. Let me turn this around for you. It's a little difficult in this light. Maybe you can see that. But I marked it out with a scriber. I first turned this part down with this carbide tool, and I got pretty close. As a matter of fact, I got, and I carefully measured, I got it to the 1 3/4 diameter that it's called for. And then I made a little indentation here basically, and now I'm using an old cutoff tool that I had. It's a high-speed steel tool, and just going in there and taking out a little bit, going in straight at the bottom part of the groove here, and then advancing it forward towards the center. So it's a little bit of a process, but it's only 1/8 of an inch thick that I have to go, so I'll keep working. Okay folks, just finished both the fitting of the back plate and the I'll show you the fit of the spindle as well. So here's the back plate with the 2 little countersunk holes for the 540 screws, and it fits on there very nicely. That's probably one of the best parts about doing this in the lathe instead of messing around with boring bars run in reverse. So tomorrow, I'll probably do this tomorrow, is take this out and put it in the mill and drill and tap those 540 holes, and I'll also bore out the 5/8 inch hole here, and I'll try to make sure that the center line is lined up and it's 2 inches on center. Here's my spindle, my 5C spindle. I'll show you what the fit is like. The boring process went well in the lathe also. Very nice fit, and I was actually hoping to get a little tighter fit and having to hone it out with brake hones, but it came out just fine as it is, so no, I won't have to hone it. And so far so good. So the next step will just be to deburr all this stuff and then get ready to take it out and put it into the mill for the boring here and the drilling and tapping there. Here's my setup. I got to thinking about the best way to hold the part, and long story short, as you can see, I left it in the 4-jaw chuck, so the orientation is still the same. I haven't unloosened the 4 jaws at all. I did have to take the mounting studs off the back of the chuck, and I moved the rotary table over to the corner. And then I very carefully went back and forth, and I centered the 2 holes along the x-axis, and I'm just checking that. I used my little coax indicator to get the exact 0, 0, 0 center for the spindle hole, and then I moved it over 2 inches, and I put a 1/2 inch drill inside, because the core hole is a 1/2 inch, and voila, it's perfect. So I will be drilling that. I'm probably going to do this tomorrow because it's starting to get cold again out here, but I'm really happy about this, and just a little idea about gripping unusually shaped parts. Hey folks, just tapping the second 540 hole here. I would say if you don't have one of these tiny little tap handles, they're really handy for tiny jobs like this. So I got several that came in sets that I had. So I'm going to finish this hole and I'll bring you back in a second. We'll check the fit on the plate. Okay, here we are with the back plate installed and the 540 screws there, and the 5/8 inch hole is bored, and here's the little stub of the same material that I use in the Quorn for the tool plate mounting. So very excited about how this came out. Stay tuned. I'll kind of take it out, put it all together, and do one more little quick wrap-up segment before we call this one quits today.